Alright, so we started off last time with the functions and procedure. We discussed what are functions, and this is the only part which is left in assembly programming, how it is implemented. We talked about the instruction memory and why we categorize memories into two different portions: to store the data and refer it as a data memory, and to store instructions and refer it as instruction memory. Okay, and we also discussed that the instructions are stored from, you can visualize it from like bottom to top. So the first instruction is stored at the bottom and the second one on top of it, and so on and so forth. Okay, we discussed that the what instruction we can use to execute the function, to call the function. I'm just wrapping it up quickly, but again, we will as soon as I hit the today's topic, I'll slow down my pace. So JAL is the instruction which is used to call the function. So this function is the name, the label, which corresponds to the address where the function is starting from. Okay, and what does RD corresponds to? RD is a destination register which is used to hold the address of the instruction next to be executed after the caller function. Okay, so I have modified some slides which I will replace with the current one that you see it on Husky CT. So destination register is also referred as return address, which is used to hold the address of the next instruction to be executed. Okay, so we have the instruction which is calling the function. So once the function is called, that entire function is executed, but it has to return back to the next instruction, right, after the caller. So RA holds that address of the instruction. And the next thing which we talked about was the JALR instruction. So whenever we execute a function, it contains all the instruction that is supposed to be executed in a function, and in the end we have the JALR instruction, which helps us jump to the instruction which is supposed to be executed. Okay, and this is the example which I started discussing but finished because you guys were exhausted. So suppose this is the code. Again, I'll give you with some interactive examples. So main is just a label. Okay, it corresponds to the address of the instruction. It could be any address, let's say 1000, 1004 or something like that. This is the actual instruction. So when it is executed, we have to capture the address of the next instruction, which is stored in RA, what we call as the return address. Okay, so when this instruction is executed, it sets PC equals foo, which means that wherever foo is defined, this is the function. Okay, wherever it is defined, PC will start executing the instruction, next instruction from here. But we have to preserve the address of this instruction also, so that we can return back to this instruction. Okay, so RA, which corresponds to X1, will be holding the address of this instruction, whatever the address is, main plus 4. Okay, once this instruction starts executing, the foo again corresponds to the address of the instruction, of the first instruction of the function. It starts executing whatever the instructions are written here. Once this function is finished, then we have this instruction, jump and link register instruction. So it helps us jump to the address stored in X1. And what is stored in X1? X1 contains the value of main plus 4, this one. So it will jump back to this instruction again. Okay.